Hey guys, so here's the second video. We're going to work on the right side of your sheet here. We're going to do some more multiplying and of these complex numbers. So this one simply, if you already haven't figured it out, is just simply distributing. So what you're going to do is you're going to distribute the outside number. So now we're going to have, let me get a little bit less skinnier color there. Okay, so it's going to be negative 5 times 4. And then we're going to do the real, multiply the real numbers, the real parts. So negative 5 times negative 6, which becomes positive 30i. And you're all set. So remember, we have the real numbers on the left, and then the complex numbers, the imaginary part of the number on the right. Now let's look at this one right below it. This one I actually want you to do it on your own. So try it out on your own, pause the video. Okay, so now you should have tried that one on your own, this one here. So I'm going to go ahead and work through it with you. Okay, so now we're going to distribute that 3i into both of these terms inside the binomial. So now 3i times 4, well, just simply 12i, and then 3i times negative 2i becomes negative 6i squared. Now we're not done yet. Remember, if we have an I that's to the power of 2, 3, or 4, we can simplify that. So this 12i doesn't change. But if you look back on your powers of I sheet, we can see that I squared is the same as negative 1. So now just multiply it through. Negative 6 times negative 1 makes positive 6, and that's plus 6. But you're still not done, because we have the imaginary number on the left and we have the real number on the right, but it needs to be the other way. So now you're going to write it like this, and that will be your final answer. Okay? Now let's go back up here to the right, and what we're going to do is we are going to multiply this out. And in this case, you have two binomials multiplied times each other. So not just one term on the outside of the parentheses, but now you have two binomials with two numbers on the inside. Now what this box is for is it's going to show you how to multiply these out. Now some of you guys may have already learned or remember this term, FOIL. And what it means is the first, outside, and inside, and last. And remember, it just refers to which ones you actually multiply as you work through the problem. Okay, so the first terms would be the ones in the front or on the left side. The outsides would be here and here. The inside would be the two in the middle. And then the last would be this term and this term. So what you usually do is you multiply each of those first. But the way I'm going to show you is a little bit simpler. You just draw a box, and what you do is you write your first binomial. So let me erase all this. You write your first binomial on the top. So 3 and then negative 2i. And then you write the second one along the left side here. So you write 4 and 5i. And what you do is you just multiply those terms that line up in those boxes. So 4 times 3, 12. 4 times negative 2i, negative 8i. 3 times 5i, 15i. 5i times negative 2i is negative 10i squared. Now remember, we're not done with that one because it's I squared, so we can simplify that. And I squared is the same as negative 1. And so negative 10 times 1 is, negative 1 is 10. So now all you do is just add all those terms together. So now 12 minus 8 plus 15i, minus 8i plus 15i plus 10i. So now just combine the real parts. So 10 plus 12 is 22. And then negative 8 plus 15 is positive 7, or 7i. And there's your answer. Okay? So like I said, what you do is you put the first binomial on the top, and then you take the second binomial and put it on the side, and then you just multiply them out, and then add all the terms together. Okay? Now, this next one, use a different color this time. Let's choose, I don't know, let's do this blue color. Okay, so this next one, we're going to work with radicals. Sorry, I got a phone call. The first radical is pretty simple. And you guys have probably done this before. Okay, so the square root of 25 is simply 5. And there's a negative outside, so we're going to do negative 5. You know what? I don't like this blue. The blue doesn't show up very well against this background, so let's just do green. So square root of 25 is 5, and then remember we have this negative on the outside, so we just make it negative. Now remember, when we're working with complex numbers, we include that number, the missing number, like if it was 0i. Now in this case, there never was a complex number. Okay, so I know I told you that if you only end up with a real number, that there's a complex number out here, but in this case, we never really started with a imaginary part. So this is just simply negative 5. Okay, so this next one, you look at it and you say, well, you can't take the square root of negative 9, Mr. Osborne. Well, when we work with complex numbers and imaginary numbers, we can. But in most cases, and what you've been taught in the past, is you couldn't. It really had no use. It wasn't useful to us, but now it is. Okay? So now, you're going to break this up just like we did before with the radicals. You're going to break it up into its smallest parts. And so we have 3 times 3. And don't forget, there's a negative there, so it's times negative 1. And remember, with radicals, if there's no number, there's a 2 automatically. So then we circle the group of 2, and we take 1 out, just one number, not both, just one, and then it becomes 3 times the square root of negative 1. And we're still not done, because remember that the square root of negative 1 is actually equal to I. So now we write our final answer as 3 times, 3 times I. I'm sorry guys. 3 times I. Because the square root of negative 1 is I. So that would be the answer there. Now, this case, there is an imaginary number, so we could write it like this. Now, you don't have to write your answers when you're doing this. You don't have to put the 0 out there. But I just want you to remember that, because it will come into play later on, and it will matter. But right now, it's not a big deal. You can simply just write 3i. Okay? Alright, so let's look at this next one. Now, let's break down this 36. And I'm going to do that by doing our birthday cake method. Okay, so first, divide by 2. Then I get 18. Divide by 2 again. I get 9. And then the next number I can do is 3. So divide by 3. And then do it by 3 again. And then there's my little birthday cake candle. And then my prime factors are these numbers right here. Okay, so let's write it out. So we got negative here. And then times, then it's 2 times 2 times 3 times 3. And don't forget, there's a negative here, so times negative 1. So then what you do, and remember, there's an invisible index there. It's 2, because there's no number, so it automatically 2. So that means we circle groups of 2. And I bring out 1, 2, and I bring out 1, 3, and nothing else. So now I'm going to rewrite this as negative 1. Now, the reason I'm writing negative 1 is because there was a negative 1 in the front to begin with. Okay? That's where that came from, if you're wondering. Then times 2 and times 3. And what we're left with is that negative 1 on the inside. So now let's multiply everything out. So negative 1 times negative 2 times 3 is negative 6. And then the square root of negative 1, as we remember with the last problem, is just I. Okay? So I want you to work out the last problem on your own. And then once you're done with that, I want you to move on to the worksheet and finish that. Once you're done with that worksheet, and it's actually like a little game. You solve the problems, and then you actually have to find the path from the start to the end. So if you don't have a complete path from start to end, that means you messed up. And you should be able to easily see which one you messed up on, because if it goes off of the path, then you probably got that one wrong. Okay? So finish that, and then once you're done with all that, I want you to finish all your IXL assignments. All right? I'll probably post another IXL assignment as well for the complex numbers for you guys to work on in class if you have more time at the end. Okay? All right. I will see you guys tomorrow. Bye.